Hello everyone. Today I'm going to present our work on interactive simulation for easy decision making in fluid dynamics. Our work was inspired by a series game called Folded. With this game, many users solve the structure of different proteins, for example, HIV protein. This proved that series game with interactive simulation can be useful for research. We wanted to make a system that uses interactive simulation to solve different problems of the fluid dynamics. For example, for oil extraction, hydraulic problems, and airflow simulations. Computational fluid dynamics can be basically divided in two types. One uses mesh to solve Navier-Stokes equations. These methods have high physical relevance, but it usually takes a long time for the simulation, so these methods are not interactive. Another type uses particles to simulate fluid, like smooth particle hydrodynamics. This method is interactive, but it has less physical relevance. While the physical relevance is important for research or education, so we choose to use methods with mesh to solve Navier-Stokes equations. There are already some tools like Parallel Catalyst allows users to combine the code of simulation and Parallel Catalyst to realize live visualization. While with this tool, the simulation is still not interactive. To build an interactive fluid simulation system, we need to realize not only the live visualization, but also we need to let users to be able to change interactively parameters or boundary conditions in the interaction tool. We made an interactive fluid simulation system with the simulation running on a calculation server to get a better performance. The interaction tool runs locally connected to the simulation server. So the connection between the simulation and the interaction is an important problem to be solved. That's why we chose to use the CRISPR platform API called CF driver, which is based on TCP protocol. The advantage of this API is that it works with different CFD solvers and different game engines. It can also run in different operating systems. Then we need to choose the simulation tool. Among all the methods used as mesh to solve Navier-Stokes equation, like finite volume method, finite element method, finite difference method, we finally choose to use Lattice Boltzmann method. This method solves the Navier-Stokes equation in a different way. The advantage of this method is that it can run efficiently on massive parallel architecture, and it uses a regular grid, which let us make our system easier. With Lattice Boltzmann method, the macroscopic variables like density and velocity are represented in particle distributions functions in different directions. For example, the 3D model we used has 19 different directions. The algorithm of this simulation is also very simple. It has two steps that are collation, and streaming. Finally, we choose to use parables as our Lattice Boltzmann method library and Unity 3D as the interaction tool. Then we ran a user study based on this system to compare the interactive simulation and normal simulation. The objective of this study is to justify that interactive simulation is more efficient, and it allows users to make more attempts to achieve the task, and thus it's also easier for users to achieve the task. The difference between interactive simulation and classical simulation in our experiment is that interactive simulation allows user to continue the simulation without restart from the beginning after making some modifications. As you can see in this video, the task of for the user is to find the minimum height of the wall to stop the water wave. During the experiment, we had 24 participants in total. They were divided in two groups. One group started from the interactive simulation and the other group started from the classical simulation to avoid a learning effect. Each session has 3 scenes, and it was followed by the NASA TLX questionnaire. The data collected during the experiment are task completion time, number of failures, which means how many attempts the user has made to achieve the task. Observation time, which means how long the user observed the result between each attempt. Here are the results. For the TCT result, we can see that interactive simulation is much more efficient than classical simulation. And from the number of failures, we can see that interactive simulation allows user to make much more attempts to achieve the task. Because the interactive simulation is more efficient, which also allows user to run the simulation multiple times to achieve the task rather than analyzing the simulation result. We can also see this from the observation time, which shows that users spent much less time analyzing the result. From the questionnaire, we didn't find significant difference in overall workload, while we found that users made less effort to achieve the task with interactive simulation. In conclusion, interactive simulation is much more efficient and allows users to run more times of simulation to achieve the task, which also makes it easier to achieve the task. While the interactive simulation doesn't reduce overall workload. For the future, we plan to use the VR device for our interactive simulation to give a better 3D perception and interaction, as the simulation for fluid are usually in 3D. We also plan to make a serious game based on this interactive simulation. Thank you for your attention.